I see half of the public are former students of mine, so it's going to be like teaching a lecture. There's a bit of a set of buzzwords here and kind of combining a lot of topics, VMs, Docker, Dockerfiles, cloud platform, Millisecond, so we're going to go easy through them. It's a bit of a mashup, but we'll see how it goes. Let's start with some things that have been happening recently. We had a bunch of very interesting local privilege escalations, things that happened. You may know of copy fail, all of these things that are basically breaking containers, right? So they are root level kernel exploits. Copy failed happened in 3 weeks ago, I think, late August. Everything was, crying on one ear, laughing on the other. These things are still happening. So yeah, this is, all of this have been happening recently, right? So we have local privilege exploits happening based on the Linux kernel, which give you root access and basically render containers useless because they're going to break out of those. They are form of container escape. This one is on copy fail. It says here the kind of Linux vulnerability that gets attention for good reason. It can provide unprivileged local user a practical path to root and carries cross-container implication because it abuses share page cache behavior. So this is things that is currently happening. A bunch of people, we actually, in the university, which is not that much of a secure place, people were, hey, be sure to upgrade your servers. This is quite bad. So the takeaway from here is containers, as kind of you would know, have a great security issue. And what we want to provide here is that VMs, as opposed to containers, are essential to cloud or multi-tenant security, because if these items happen and you have a shared kernel, what then? So what we want to do is we want to use VMs. However, people will say, yeah, but VMs, they are very slow. They are difficult to manage. It's not like I'm going to do Docker run, Docker container. I'm going to use Kubernetes, any sort of orchestration. And you don't have the tooling for them. And my aim is to give you the idea that it's not the case, and what we've built, it's actually giving you Docker or container-like operations and management with the isolation security benefits of VM. So what we are looking for is we want to combine those two. We want to combine the security and isolation properties of VMs with the tooling, the management, the orchestration, the operational benefits, the use of using containers. And how we want to do this is our solution, our offering, Unicraft Cloud. This is what we call the Millisecond Cloud Platform. It has millisecond semantics. It's meant to be as speedy and as fast as possible, which is, for all intents and purposes, also the case with containers. They start very, very well. It's meant to be the go-to platform for bursty workloads. If there's something that runs now and then doesn't run, it shouldn't give you any additional costs. And behind the scenes, it uses VMs for isolation. So it's, once again, foundationally VMs, security isolation, but also should give you the entire benefits of efficiency and speed that containers provide. So in short, what we want to do is, and this is the case with the platform, build as a container, so use Dockerfiles, but run as VMs. So building and the other operations which are common to containers, you have a Dockerfile spec, they want to be used over there, but for the actual runtime, do not use containers, do not use C groups or the, let's say, imperfect isolation that's going to be subject for ALP attacks that you saw earlier. So build as containers, run as VMs. And how do we want to do that? So what we want to get at is to get a file system, a Docker image, and we have a Docker file for that. This is the typical way you're going to construct any sort of image for containers. We want to do that also for us. So we're going to use a specific API, in this case, the Unicraft API or the Craft API, which is going to take the spec and build you the OCI image, the actual file system. This is the same as Docker build, right? You create the image, and then you can make use of it. And then you, as the user, you're going to be the one providing the Docker file and make use of that. So for all intents and purposes, if you're using containers, you're going to use the platform, because the interface for you is going to be the same. You're going to start from a Docker file, build it, and then eventually run it. How will this happen as a full picture? You have the application file system, which once again you built over here. So this is the file system. You have it over here. You combine it with a kernel image, and then these two are wrapped together in an actual image that's going to be used by the VM. So if you compare it to a container OCI, the difference here, you also have the kernel, because this is going to run as a VM. You're going to then push this into a registry, so it's a similar registry as any other, and our testing is with multiple of them. Andrei here is looking now into ECR, but the others work as well. We have our own registry. And then after that, you're going to start a VM. We have an instance creation feature that is similar to, let's say, Docker run, where you instantiate, or Docker create, if you will. You instantiate a given VM instead of a container based on that image. So, okay, that gives you an overview of why should we use VMs and how everything kind of nicely wraps together. But the idea still remains that VMs are slow, they are clunky, they are huge, they are difficult to maintain, and how do we make proper use of them on cloud? And what I want to provide you is some, let's say, short description of how the cloud works and what are the issues, and how would we solve them with VMs, and then demo them to you. So on the cloud, the kind of very, very simplistic way is we are here, we want to run an application, we send the request, we get the request, and that's it. Nothing out of the ordinary. Generally what we do is we have we are the clients, we deploy our own application in the cloud, we make a request to that, it's processed, going to be received. Nothing new here, everything is as supposed to be. So quite simple. The application there is either a container or it could be a VM in what I'm trying to sell you. Then the idea, okay, how would this work? Does it make any sense to have it working like this? Well, there are some issues here. So this is your typical deployment. What are the, not issues per se, let's call them challenges, right? So what can happen? Well, firstly, you can have many, many requests. So you want to then be able to scale them or to serve many requests coming at the same time. How do you do that? Where you use Kubernetes, you scale, you run multiple pods, nodes, whatever, you start them up, you serve them, you get back, and then something like that. That's the typical way you're going to do it. Another thing is, you have this, but then you have one application, but you have multiple applications. You can run different of them, so you need different containers or different VMs, and you have to spread them, you have to proxy them to each of them, you have to know what reaches what. It's a challenge to solve. The other thing, you have multiple clients. You have multiple clients, each making their own request to multiple applications running on the same infrastructure. You want to serve them quickly. So how do you do that? And finally, you have this. What is this? There are no requests. What if there are no requests? What do you do with these applications? Do you keep them running? Why would you keep them running, right? You need to shut them down, but then you need to start them up. So you have this level of, let's say, intermittency. It's burst, you serve them, and then nothing happens. And then what do you do? Do you keep the compute nodes running? Do you still waste memory and CPU? What do you do with that? And on top of it all, what you can do is you can have this. I'm going to have one request, then I'm going to have no request, and then I'm going to have another one request, and then request multiple applications or multiple requests, and they're going to have this workload which is going to be very variable. Multiple clients, one client, multiple applications, one application, no application, multiple requests, no request is going to vary all the way. So how do you handle that? Right? How do you handle all this variability, and because what you're aiming to get is, in the ideal world, security, efficiency, fast responses, and of course, low costs. Ideally zero, but well, that's imperfect. So low cost, you want it to scale easier, and you want to have it isolated. How do we handle that? And let's see how do we handle that actually in Unicraft Cloud, and how would this happen here. This is a list of instances that are already there, which I'm going to demo, but I'm going to take it one step at a time. Let me just, for starters, going to demonstrate a very simple, this is going to be kind of a lecture-like demo, just to see how things are working. What I have here is I have a very, very simple node application. What it does, it's amazingly, it's complex, it prints hello world, right? So that's all I can do with node. I'm better at C, I can make it also print by world. So I have this application over here. There is a Docker file for it, which is a quite simple one. We did this an improvement here, so we made it from scratch, so it's going to be minimal, but it's a Docker file for all intents and purposes, right? I'm going to build this. So behind the scenes, it does some sort of Docker build. You call this from Docker, and then the build image is going to be here, is going to be sent to a registry remotely on Unicraft Cloud. If I'm going to use something like, I think I had an images list here. It's going to take a bit of a while. You're going to see this HTTP server node is an actual image, the first one that's available in the registry. So everything is OK there. Then what I'm going to do, I have this, I create some scripts just to make my life easier here. I created this, what I call create instance role. It's a bit of a complex command. It does, I mean, it's like Docker run. It says this is the image, you get the name, you get some sort of memory, and then I'm going to deploy it also with the port mapping. So it's very similar to Docker run, okay? And I'm going to start this. So I'm going to read this instance, and now, after I created it, it appears over here. It's the first one, right? What can you notice about this instance compared to the others? What strikes you? It's the obvious. It's running. It's constantly running, right? Why? Because that's how I created it. I created it to always run. What are the benefits of getting it to constantly run? Well, if I'm going to curl it, sorry, I'm going to very, very quickly get a hello world response, right? It's because it's running, it's already there, right? It's running, it's there. The problem is, if it's running, it consumes resources. I don't want to consume it resources. So what do? I have this other script, which is going to say create instance, and I'm going to call it S20, which actually means scale to 0, but you can read S20. So scale to 0, and I have a policy here which says policy on. So I'm going to scale to 0. Let's see what that is about. So I'm going to create it. I have this instance here, and you can see the instance is standing by. Bear in mind some items. One of them, start count is 1. It booted in 140 milliseconds, which is quite a bit. It took about 250 milliseconds to be network ready, to be able to serve. And it was up for a while, but now it's asleep, so it doesn't consume any resources. The downside, if I'm going to curl it now, once again, these are all VMs. So there are no containers, they are VM. The interface is similar. If I'm going to curl it, it's going to, of course, give me the response. But you can see here, it now started 3 times, but each time it's going to start from 0, right? So that's what I call it. I'm going to do another curl, two other curls. The two of them were very, very close to each other. So if I'm doing very quickly, it's going to just increase by 1. But you can see the boot time is still 60 milliseconds, 140 milliseconds. It takes a while. Can I make this better? Yeah, I can make this better. I'm having another script here, which is going to create instance S20 stateful. The difference here is we have the policy on, and we have the statefuls equals true. What does it mean? Let's just start it and see how it goes. So right now, if I'm going to see here, this is the stateful one, the top one. Network time is a bit larger. We're going to see about that. So now if I'm going to curl that instance, and I'm going to say HTTPS, and I'm going to curl it, okay, it's going to, yeah, that's the correct one. Let me curl it twice, and then let's list it. What is the boot time now? Compare the scale to 0 with scale to 0 stateful. The boot time is 5 milliseconds. This is what we call millisecond semantics. The net time is 26 milliseconds compared to 150. And you can see here, it's scaled to 0 and stateful true. What does that mean? Whenever the instance is supposed to stop, and stopping happens when no traffic appears, so it's going to go to sleep by itself, it will create a snapshot of the memory, and then when it's going to resume, it's going to resume from that snapshot. This one starts from scratch at all points in time. This starts from a snapshot. Okay? And that's going to give it very, very quick times. There's obviously the downside. What is the downside? Storage. Yeah, you're going to store it. We actually had a problem 2 days ago. Some guy had 1,000 instances, and each instance was about 1 gigabyte of RAM, and he managed to fill an 800-something gigabyte disk. So there are caveats to that. You can do compression. So there are some alternatives to there, and you can choose your policy. The policy is called MTSS, which stands for multi-tier snapshotting. Yeah, it's a very interesting. I didn't come with it, but I like it. So you can do all that to improve it. Let me just create this instance again, another instance, stateful instance. Can you tell me what is the difference between the two entries? The first time this one goes, it still has a boot time and a net time. And imagine you want to start a bazillion VMs only once, because there is this use case. I just want something very quickly and once. Even with scale to 0, even with stateful, the first time you start it, it's still going to start from an image. It's going to start from scratch. And you get these bad boot times. These are not milliseconds, they're not milliseconds, so it doesn't work. So what do we do? Well, what we're going to do is we're going to look into the something that we call create templates. And I'm going to see here, create instance from template. Boot time 4 milliseconds, net time 26 milliseconds. What is that? What does the template do? Let me show you here in this script. If there's an environment variable called template, I'm going to write one to this particular file. When I run over there, I'm going to command the platform to create a snapshot of that instance, and then that snapshot is going to replace the image. So I'm going to create an instance of VM, not from an image, but from a snapshotted variant of memory. And now whatever I'm going to create extra, any sort of new instances, they will all have millisecond semantics. Of course, there's going to be a bit of storage, but now I'm going to start everything from scratch. Every new, from zero, from scratch, new instance I will create will be this. And you say, yeah, but that's the case with Node. What about something else? Well, I have here an example, and you saw it earlier, of a browser. We have OpenClaw deployed, and this browser, we have the TPL browser. This is for a template. This has a huge Docker file. Where was it? In image Docker file. It's a pretty large one with a lot of things, but I'm going to again create instance from template, and this is going to create new browser instances, and all of these browsers have millisecond semantics. I'm able to start 4 gigabytes VMs and be ready to serve in 530 milliseconds. And you may say, yeah, but it doesn't work. Well, actually it didn't work this morning because of an error we had, but now I'm going to show it works. So I'm going to call this, I'm going to have to trust me that indeed it does a screenshot of Google. So what this does is, if I go here, I'm going to curl it. This took a screenshot of Google. Let me do another screenshot, okay? So what this does, if you're going to check here, you see here it started 3 times, everything millisecond semantics, even the first one for an entire browser. I want to do a screenshot, start an entire browser, a huge variant of that. We have also headful, headless, whatever you want. It takes 5 milliseconds to boot, 30 milliseconds to be net already. You do the screenshot, you go to sleep. Everything having to do with VMs. So that's kind of the story here. So what we have here, what I just demoed it, how the Unicraft Cloud Platform works. We have scale to 0 instances, meaning the moment nothing happens, instances are going to be put to sleep. When something happens, you resume the instance. Of course, this means that you're going to always start it from scratch. You're not going to consume resources, but still it's going to be slow. So we have VMs, we have low resources, we don't have speed. So what we do then is we use snapshotting, suspend and resume. So we have VMs, we don't consume resources, and now we are able to reply very fast because each request is going to resume from a suspended state, or even more so, from a templated instances, which is a pre-warm state, and on top of which you create VMs. You also have volume templates, so apart from instances, you have also volumes. And that would be it. There are some other features as well. So this is kind of for the speed factors. The other part is you can reduce memory footprint because you shared this shared file system. This is the case with, let's make it similar to containers. We can share the file system. We can do this with VMs. We have something we call ERO effects, extended reading file systems, where everything that is shared and there's a text area is going to be shared among instances. Auxiliary ROMs, which is a way to have, let's say, plugins for different instances. You have a huge browser instance or huge image, and you want to amend that. You create an instance from that huge image and something extra. It's like an executable and a plugin or a shared library. There's something we call just-in-time execution, meaning the moment the request comes in, by itself, there's a new instance going to be spawned. And combined with snapshotty templates, it's going to be spinning in 5 milliseconds. So what we're going to do is we have the Unicraft Cloud, which is a hosted offering, but one of the unique selling points is it can run on-prem and cloud-prem. You have your own cloud infrastructure, or you're renting some sort of servers or even VMs on Amazon, GCP, Azure, whatever. You're going to, or Vultr, you're going to be able to install it over there. You can deploy almost everything. You have a Docker file for it. Yeah, it's going to run on Unicraft Cloud. If it runs on Docker, it runs on Unicraft Cloud with all those benefits that you saw earlier for efficiency, isolation, and cost reduction. Cater to your needs for on-prem. You have a lot of customization options because you have the power to that. So it's not like EC2 or GCP, which is somewhere in the cloud. This is on your on-prem if you want, or on your control. You can customize it to your needs. And yeah, we are a highly skilled technical team. We have a research background. We are fairly skilled in operating systems. We basically port a lot of the OS and low-level knowledge to the cloud and to the way we think the cloud should work. And we have a constant feedback loop to support you for that. The prime use cases available at this point are databases. This is how we started with Prisma and everything. Headless and headful browsers. These are very, very important because of the AI agentic world. Functions. Very recently, a lot of people are looking into sandboxes as running their own type of applications in a sandboxed environment on Unicraft Cloud. And yeah, because it's the AI world, AI agents are one prime reason. That would be from my side. I would ask you to visit the website, unicraft.com, get in touch with me. We have the users Unicraft server, find us on social media. If you're looking, once again, for security, efficiency, and cost reduction, give Unicraft Cloud a try, and you'd be probably pleasantly surprised at what you can do with it. Thank you so much.